sharing each day. But what's really cool is it's in support of the Raspberry Pi Foundation, which is a group that is spearheading getting young folks into computer science and programming. And so I'm super excited. So with that said, I thought I'd volunteer to go ahead and do a developer topic. And of course, what's top of mind for us is the past about a year now. We've been diving into OpenAI, more the back end and the architecture side, and looking at building solutions, and so that's some of what we'll share with you today. So the title of the session is Journey into Generative AI, Building Your Own AI Copilot. And so again, it is a developer session. There are 2 QR codes here. The one at the top will give you a link to a GitHub repo that accompanies this session. There's a ton of useful links in there. I'm going to review it with you in just a moment. And then there's also a link in the lower left-hand corner if you'd like to follow up and schedule a 15-minute complimentary envisioning session on some of these topics. So a little bit about me personally, on a personal level, my name is Paul Swider. I've worked as a computer software for about 30 years, and I guess as a software engineer, it probably took me about 10 years to get to that point. So maybe about 20 plus years, mostly focused on building mission critical systems, mostly in healthcare, not all, but I would say about 3/4 of the work I've done in the past 30 years has been related to healthcare and health life sciences. And so something about me, again, from a personal side, that was actually a sneak over to the professional side, if you will. I recently just got back from Tibet. You can see these photos here in the background. I went with some colleagues and some friends, dear friends, actually, and spent a couple weeks in Tibet and hiking to Everest Base Camp. And then after that, actually, we went off and we presented around Southeast Asia at 3 different events. And I actually presented this session that I'm giving here today. So now a little bit more about me professionally. Some call me a healthcare disruptor, a pioneer in the healthcare space. I've also been part of the various Microsoft communities throughout my career. Everything from the developer certifications to the systems engineer certifications to training. I was even an MVP for a little while, and probably other stuff that I'm not even remembering right now. And I also consider myself a community builder. As a matter of fact, one of the things I'm very proud of is we've built the global healthcare cloud community with local chapters. The biggest one, the founding one, being in Boston, and so that's something I'm excited about. And so I'm currently based out of Boston. And when I'm not in Boston, I like sailing. I love going and seeing family in Puerto Rico and sailing. And so with me, let's dive into it. With that, let's dive into it. And so I'll start by giving you a brief about the developer repo. Again, the QR code is here in the lower right-hand corner. And let's get started. And so our agenda, we'll talk about what is a Copilot. So we'll talk about Copilot definition, and we'll start right away. So it's a developer session, so we got to start right away with the demo, and then we're going to look at Azure OpenAI Studio and some stuff we need to know there. Semantic-kernel is a core repo that's core to this topic. So we'll dive into that a bit. We'll discuss this topic, chat with your data, and then we'll look at something called prompt workflow or prompt flow. And then finally, we'll discuss AutoGen and multi-agent. And so what I would submit to you is that by the end of this session, you should have, the goal is to give you a very good overview of all of the different parts and pieces available to you as a software architect to design enterprise solutions and mission critical solutions that that are infused with not just large language models and ChatGPT but also at machine learning models and other Python code and functions, etc. And so I'll talk about that as we go through the session. And so again, let's just start right away with the demo. And the first thing I just want to pull up is the site for the charity I was talking about, the Raspberry Pi Foundation. So this is at Just Giving. There's a link on the easiest way to get to it is to go to the Festive Tech Calendar website, and there's a link there where you can get to the Just Giving page. So this is the developer. This is the repo that goes along with this session. The key thing to note, there's a lot of great stuff in here, but all of the stuff that has to do with this session, the links, all the repos are right here on the front page of the README. And there's also some additional technical resources you might be interested in. There's some executive content as well, but since this is a developer session, I'm only pointing out the developer content. And so again, the QR code in the slide deck will bring you to this repo. This is my holiday gift to you. We'll keep this updated. Essentially it's a stopping place to get fast links to how to do this stuff, if you will. We don't actually put the content here. We link to Microsoft Learn. Microsoft Learn it's just let's just say, help content and how-tos have come a long way over the past couple of decades. And Microsoft Learn is a pretty impressive learning playground, if you will. And so what we do is we provide links to Microsoft Learn and also to various GitHub repos. Quickly, just let me mention this too. Last week at Ignite, and there's a big announcement. They announced just a ton of different co-pilots all throughout. And we knew this was coming all throughout the stack. And even here today, I'm at Microsoft Times Square today. I'm actually streaming this from my hotel room. I'm here at Microsoft Times Square because there's a Node Healthcare conference actually at the Microsoft MTC event. And I can tell you that the entire event is focused on AI and generative AI. And folks are just abuzz at the possibilities, if you will, available. And so with that said, now let's move into actually, a demo of what a custom Copilot might look like. And I guess we should start with definitions first. And so what you're looking at here is a Copilot. It's been lightly customized. It actually comes from the semantic-kernel, the code base, and I'll talk about that in just a couple minutes here. But let's just first acknowledge that, when I say Copilot, essentially what I'm talking about is a chat-enabled application that's integrated with some business software as well, and it makes use of AI technology to assist the user along in whatever tasks or I should say tasks, right? Could be multiple tasks as well. And so let's just use that as our definition for what a Copilot is. And let's also, again, in my previous tab, you saw Microsoft announced I heard somewhere around 100 different Copilots are up to now. Please check that. I'm just guesstimating that was heard. That was heard secondhand, but certainly a lot. There are a lot of Copilots, and we now know that Microsoft is all in on this new architecture as well for developing applications. And so we already. I'm going to go into this session with the assumption that you already know what Microsoft Copilot is. Basically what a Copilot is. I'm guessing you've probably seen demos of a Copilot interacting with various, documents in Microsoft 365. I'm going to assume for this session that there's some, understanding of a basic Copilot concepts, if you were. And so the use case for a private or custom Copilot, the use cases are unlimited. And I would submit that we'll probably see many of these. In some organizations, they may have just as many as they do, apps or web apps, in over the next years as they continue to build out this new infrastructure. And so, and I think you'll understand why as I start to go through the session too more. So I don't want to linger too much on that, because I think some of the use cases will become a little bit more apparent while we're continue into the demo mode. But let's just list one obvious benefit right away. Notice that here I'm logged into I'm logged into Entra ID, right? So I've authenticated into the Copilot, or at this point, really, it's just doing chat. So it's a little bit of a push to call this a Copilot, because we don't, at this point, really have a lot of business sort of integration, right? I'm going to show you some of that as we do demos, how we, what we can do and how we can add that. But let's acknowledge that most of the functionality here is around chat. Although, with that said, if I click on the plugins icon up here, notice that this code base has the stuff built in to handle plugins as well. So we can enable plugins in our custom Copilot here. Again, I'm logged in security. Of course, I can go ahead, create new conversations. Notice the conversations are labeled as bots here. Again, it's just a code out of a sample from semantic-kernel. So and you can see that if I go ahead and refresh, there's no smoke and mirrors here. This is running locally on port 3000. This is a Node.js application, and it's a multi-tier application. I'm going to go through the different tiers throughout this presentation, but what we should acknowledge at this point is, essentially this is what I'm talking about when I'm talking about a custom Copilot. Again, it's a secure environment. In this example, our Copilot is built using Node.js. The web API is in Visual Studio, and the backend models are managed using Azure OpenAI service, and they expose endpoints that are web API calls. So it's actually a really great scalable enterprise example of private GPT, if you will, or private Copilot. So now let's go on. Let's figure out, let's talk about some of the next steps, right? So how do we actually build this thing? How do we make this stuff happen? So the first thing that I want to point out to you is, so for developers, is let's just acknowledge, first of all, that we've been living in this world of cloud native apps for some time now, right? And so this is essentially what that looks like, right? And you've probably seen this many times in different formats, etc. I highlighted a couple things I wanted to call out because I think they're going to be useful as then we look at this new architecture for AI apps. And so, of course, we have the authentication piece, right? In our case, it's Entra ID, formerly known as Azure Active Directory. We have the web front end, right? So this is our user experience. And then we have the data tier, where we have data that's stored and accessed. And I'm actually going to take a little bit of a leap here, and I'm going to throw some of the LLM stuff into the data tier, if you will. And then, here, this falls under, is actually a little misleading because it shows a web front end and then it has functions, but they're not really showing any business logic here. So what I would submit is that often we'll have a tier where we separate out, the business logic, if you will. And so this is what we've been doing forever, right? So now here's where we are today. And so things are fundamentally different in that the way we build these apps at the most fundamental level is different. And so, for example, if we look at in building a native cloud app, one of the very first things that you learn how to do after you do Hello World in a web app is you learn how to store the state of the application, right? You write a value to a cookie most of the time is how you do that. And then what that allows you to do is to read that value on the second page, right? So you have just learned, you went from Hello World to storing the state of page 1 and then passing it to page 2 and printing Hello World on page 2. And that's how we manage state in apps that we build today. Now, what's different here is that we we have this new concept of memories, and they're fundamentally different in that when we're storing key value pairs in cookies, we retrieve the data in a very specific way, right? We say, go to this cookie, go to this value, go to this uh, variable, if you will. Well, I'll call it a variable for right now, and retrieve the value, right? It's a key value pair, and if it doesn't match exactly, you don't get the data back, right? So here's a little bit different because, again, what we're doing is we're dealing with this new concept of memories, and one of the things that we have to realize is with this conversational type data and these large language models, the data is oftentimes persisted in vector format, and so it's encoded in a way that when you're looking for the value, it's not going to do an exact search on key value pair. It's actually going to search on not only things that are a perfect match, but things that are likeness, right? And so you may have heard the term semantic versus syntax. So syntax would be, field name equals this, and you filter, you get a return. With the vector embeddings, and vector memories, it's fundamentally different in that we have, a vector that's multidimensional, and it's essentially it's embedding in a way that that allows us to do these near searches or find items that are like, if you will. And so that's, right out of the box, right away. So the minute we even just start working with state, things get different, and we have to learn all about, how we deal with vector databases potentially, and how we create embeddings. And then oftentimes, as you start to run with this, I don't want to dive into this too much at this point in the presentation, but then it can get pretty complex as you continue to use embeddings to train, if you will, with your business data. Now, don't let me scare you there, because when I say that, it's not really training in the sense of training the model. It's an augmentation, and I'll explain that as we a little bit as we go along. Again, there's only so much that we can dive into in the 60 minutes here. But the key thing is that fundamentally at an architecture level, we design these things differently. And we'll keep zeroing in on that as we continue with our demos. So real quick, this is what the AI stack looks like. So we have the bottom, the ML platform. We have customizable models, services, and then at the top, we have our applications. One key thing to note is that everything in these two rows here, so this would be if I'm coming up from the bottom, row 2 and 3, I want you to remember these as we start to talk about prompt flows and prompt workflows, etc. And we may even come back to this slide, but the gist of it is these are the types of things that we can execute from a prompt flow. Okay, so now let's dive into more demo stuff, and we'll probably spend most of the rest of the session doing demo stuff, if you will. And so we looked at the custom Copilot. We'll come back to this, but now let's start looking at how we built this thing. So remember, I told you that I want to think about this in terms of the user experience, business logic, and then the data tier. And that way it should allow you to conceptualize how things are different, here compared to how we used to do things. And so one of the places I'm going to start is with my deployments. And so I actually have multiple. I have GPT 3.5 and GPT 4.5. I'll show you 4.5 here in another demo shortly. But the gist of it here is that we use AI Studio to create new deployments. And the deployment is basically we're deploying a machine learning model, and it doesn't have to be OpenAI. It can be open source. It can be Llama. It can be, there's videos on how to do Mistral, the new 7B model. So really interesting and great to see Microsoft is supporting, multiple models, multiple vendors. Now, there's already a lot of content and demos on Azure AI Studio and how we deploy models. So I don't want to spend too much time here, but what you should know is that this is where we deploy our large language models. This is where we can also go ahead and apply content filters to do additional filtering on top of what's already included. And then there's, of course, a playground where we can test the models and work with completions. So you can see there's, a chat window here. You can, start, typing various things. You can speak too. I accidentally hit the microphone, but I'll just say, let's see what it says. So I asked, there you go. So, I asked it about scalar functions and it gave me back some stuff. So it's just a playground. And again, I don't want to spend too much time here because there's already a lot of content and demos about this. But once we have that deployed, then what we can do is we can start to use the semantic kernel to build out the demo Copilot that you saw. And as a matter of fact, the bulk of that code has only been modified lightly. It actually comes from the samples directory in the semantic kernel repo. And I'm not seeing it here now, so they may have moved it. I know there was some updates last week with Ignite, and I'm sure it's in the samples are in here somewhere. We actually forked the repo, and so we'll have them for our demos. I'm actually just looking at the one live on the Microsoft site here. And so we're going to start with semantic kernel to build this thing out. There's step-by-step instructions on how to set up the sample app and how to get it running. And the best way to really see it is just to look at it. So what I'm going to do is actually open up the part of the repo anyway in VS Code. And so what you're looking at here is this is actually the Node.js app that represents the chat client. But where I want to go next, because remember we started with the Azure OpenAI Studio and we deployed our model. So we said, okay, that sets up the back end and gives us at least a piece of what I would, go ahead and call the data tier. And so now what we'll do is we'll look at the web API. And so this is in C#, this is in Visual Studio, and you can see, and again, this is in the repo. You all have access to this. You have the links and everything now. But if I come in here, you'll see that you can see the details of the project. So here's Copilot Chat. You can see the various different controllers, the chat controller, the chat history controller, right? So the chat history controller, this has to do with the memories that we were talking about and how we're going to read. I think of it as sort of the state, right? Similar to the state that we've dealt with historically, but now doing that here with these types of apps. And so you can see where it's, creating SignalR sessions and going back and forth and handling all of the chat stuff. And it's very verbose. And notice they have a speech token controller as well. So you can pass speech through the API. So this is the middle tier. This is the API. This is the business logic in this example. And it's up and running now. This is a live demo. Anybody that knows me, they know I do live demos. So there's no smoke and mirrors here. So this is the actual Visual Studio, which is the middle tier, the business logic. And then I've just opened up a developer developer prompt, and I did a .NET run, and so that's basically spun up the web API, the middle tier. And so you can see they've got the hubs in here, models that match up to what's in ChatGPT. I'm sorry, our Copilot client that looks like ChatGPT. And so I think one of the things I want to show you while we're here in Visual Studio is this notion of a chat message and how the chat message is persisted, and how we also have something called a chat message type where we can determine the type of message. Now, this is important as we go along and start diving into some of the complexities of building these applications. So I'll continue to expand on that a little bit. But hopefully you're getting the point here. This is our middle tier. This is our web API. And again, this is in C#. You're looking at it in Visual Studio. And then and it's up and running right now and on port 40443. And so then we move along. So again, we did the back end. I showed you Azure AI Studio. We deployed the models. Oh, by the way, one of the things I should tell you in case it's not obvious, that we have a configuration here, right, that has API keys to get back to OpenAI. So it knows how to find that model. More importantly, it knows how to find the deployment. Okay, the deployment name is different than the model name. And then given that configuration, then the web API can find the backend and do what it needs to do. So then moving along, so now let's look at the user experience. So now we go to the front end. So this is the actual Node.js application. And so this is, to refresh your memory, this is this part here. And again, no smoke and mirrors. This is running on 3000. And you can see it's finding the back end on port 443, boom, and it lit up. And by the way, notice it's remembering my conversation. That's the memories. That's like persisting this conversation, persisting it. It's the default here is it's doing it on the file system, persisting it in vector format. And then the big announcement that was made last week regarding this at Ignite is now in the semantic kernel. It will take responsibility for managing that chat history for you. So that's been flushed out a little bit more, if you will. And so it's less work that we have to do as a developer, managing this chat history, reflecting back on it, etc. There's new APIs and functionality that allows us to do that. I apologize for the pop-ups here. I probably should turn off my notifications, but it is what it is. And it's only a one-take session. So I know it's going to be a little bit rough, but hopefully you're enjoying the authenticity of it, if you will. And so now let's look at the code for this. So so that's the front end. And so again, remember, so here's the web app folder. And then if we go into the source, you can see the different libraries that have been created that help the semantic kernel essentially do its thing. And then various components for the chat. Here's the chat history component, for example. So here's the code for this. And what's really fascinating is so now the next thing you would want to do is you would want to start building this functionality out, right? So now we want to really turn it into a copilot. So far, it's just sort of chatting back and forth, right, with the large language model, but it's not necessarily integrating with business data, et cetera. But let's talk about taking the next step now. So for example, one of the very first things, if we were going to take the next step, is we may want to, based on the type of question, call a different model, which, yes, you can do that. So for example, one of the things, this is real life, one of the things we're working on right now is we do a lot. You heard me say in the healthcare industry, we have a co-pilot that helps hospitals and hospital systems on the operations side, managing the hospital, healthcare administration, et cetera. And so we're going through the process now of integrating that and integrating it into line of business applications, but also extending it to other language models. So here's exactly what I mean by that. Let's say a doctor is using this copilot and the doctor asks a question. Tell me about my hours last week and how much I'm going to get paid, that type of thing. Well, we can go get that data, query PeopleSoft, ground the model, do RAG, basically send back a response. And all that works great. But now what happens if the doctor types in a clinical question? What happens if the doctor types in, how can I, treat a broken bone for a 9-year-old child or something like this, right? So what will happen is I want to detect that that's a clinical question. That's not a business question. And so we shouldn't be answering that question most likely with the business language model. We'll want to send that to a model that's been finely tuned for clinical use cases. So it's a really great example of how you would start to extend this and tie this into business systems. So if we submit that, if you accept everything that I've told you, then the next thing that we would have to do to customize this code to make that happen is we would have to add a new chat type. And then we add, once we added the new chat type, we would need to then take the next step. And so what I found on Hugging Face, so Hugging Face is an open source community that you can think of it as GitHub for machine learning and AI. So on Hugging Face, there's a model that all it does is predict if a question is a clinical question. And so I'm going to stop right there with that, but it's really important that I shared that with you because it's going to make it a lot easier to understand what we're about to talk about next, if you will. And that is prompt flow and chatting with your data and like all that cool stuff, like taking the next step. Once you want to start integrating. Oh, real quick, they just announced at Ignite last week as well. There's a new Azure chat repo that is basically a different version. Is a different flavor of the chat app, if you will. And I just lost my place here, so bear with me. Sorry about that. Yeah. Okay. Yeah. Okay. Sorry. That's my train of thought. We were talking about prompt flow and I was distracted quickly because I thought I was in the wrong place here. So Azure Chat was just announced. It's a different flavor of this is what I was trying to tell you. So you can, check it out here. There's a repo. Here's a screenshot of what it looks like. Or is it? I thought they had a screenshot. That's part of it. I'm sure they do somewhere. You can find it, but it's basically it's a chat application that can be extended into a Copilot, etc. Okay, so now moving along to the next topic in our agenda is chatting with your data. And so one of the first things that you should note is, yes, there is this new, it was just announced, Chat with Your Data Solution Accelerator, now available on GitHub. And so I highly recommend you check this out. I've already put links in the repo that I shared with you, but you definitely want to go check out the accelerator and the pattern. The basic idea here is that we can ground our data in we can ground our model using business data. And so you probably heard the term RAG, or retrieval augmented generation. Gosh, look that up. I'm sorry. It's a little bit early here. But the basic concept is that the user asks a question that's, real world here, what is my FTE? What are my hours from last week? And so what we want to end up doing is we want to actually make a call in a very structured way to get that query, if you will. And so let me show you actually what I mean by that, because it was a little choppy. So if I look at this example here, here's a great example of doing some RAG stuff. You see this one is setting up, so it's a Python code in Notebook. And you can see the first section of code, it's setting up a connection to Cosmos DB. And then what happens is down here, this is where it starts to structure the prompt. And see, it says query prompt equals, this is really small, so I'll read it to you. And it says, write a Cosmos DB SQL query for a container with data about hotels. It has the following JSON schema. And then it gives it the actual schema for the table. And then what happens is there's a couple of functions that get created because we can call functions now. There's one query hotels and one for booking the hotels. And so that code sets us up so that we can actually pass a system message. And so you can see here, we're passing your helpful assistant, assisting what hotels are available. But the point is, we're being very precise with the definition of the prompt. And then here's the actual code that pulls it all together. And then what you can do is you can run your agent, and you can see it'll run the query, return the values, et cetera, et cetera. So this came from an engineer at Microsoft. It's fairly new code. We've been playing with it and actually modifying it to pull from SQL. So if I go to here, and let's go. Hold on one second. Yeah, I thought it was in here. We have. No, I'm sorry. I don't have it. I don't have that code. I don't have that notebook readily available. But essentially, what we've done is we've changed the. It's actually not even a notebook. It's in VS Code, and I don't know where I can find it. Essentially, what we've done is we've modified the Cosmos DB code to point to SQL Server, and we are able to to get some. We are able to get some meaningful stuff back from the database. It's creating the SQL statement as as we would expect. So anyway, that's what I get for going outside of. I wasn't prepared to demo that code, but when I was looking at this, it just occurred to me that it's something I wanted to share with you. And so this is a fairly simple case of RAG, right, and grounding our data with business data. So we're going off to a SQL server. In this case, is Cosmos DB, and then returning that to be processed. So then the next thing I want to take a look at here is this concept of chaining these prompts together. And so there's this something called LangChain, which is this is third party. It's an open source community, if you will. And essentially what it allows you to do is to start to chain together some of these prompts. And so I have code here that it's going to install some Python modules, and then it imports some dependencies, and then it sets this up so that basically it can connect to SQL Server and start running LangChain against the database. And so again, LangChain, it's a series of prompts that are executing as one or more agents. So this is interesting because what's happening is it only knows about the SQL Server. So up here, I can't show you this code because I have our SQL Server stuff is up here in our API key, but essentially we're connecting to the server, and then what we do is we run the agent. And in this case, we're just going to use the sample Titanics database. We are working, we have some production FTE here stuff, but to keep it simple, because it's live data, I'm just going to do Titanic passengers. And so what happens when I execute this, again, you can see no smoke and mirrors, the thing's actually running. And what it does is it starts a new chain. And you can see that the first thing it does, the action, is it goes off and it generates a query to return all the tables from the system tables database. Is a table that holds all the system, all the tables, if you will. It's a system table. And so you can see it found 3 tables here: Titanic data, and the physician FTE reporting repository. And so and then it has a thought. So it says thought, the relevant table is Titanic table. I should query the schema of that table to see what columns are available. So see, now it's working. It's multiple prompts. So now what it's doing is it's using a create table script so that it can figure out what the columns are. And then it runs it. It says, oh, okay, I know I'm right. Here's some data. And then it says thought, I can use this data table to calculate the average of the passengers, and then go ahead, create the query, select average age from Titanic data. That's not hard coded. That was generated from the agent. And then the answer, finally, the average age of the Titanic passengers is approximately 23.8 years. So that is, I think, super cool, super powerful. I was blown away by that. We've been working with LangChain for a while now. But then what was really super cool is Microsoft recently has introduced something called prompt flow. And again, there's a link to this in the GitHub repo. And so what prompt flow will allow you to do is basically you can think of it as like workflow for your prompts. So it does exactly very much like what LangChain was doing. It allows you to create applications that have workflow, and prompts can be associated with each other. Microsoft's actually taken a step further, and with another repo I'm going to show you that allows you to build multi-agent solutions as well. And so this is prompt flow. And one of the things that I need to show you here is that this is very cool here, is that there's actually a new Visual Studio extension for prompt flows. So this was announced last week at Ignite too. So here is, let's scroll down. Here is my prompt flow extension. And then once that's installed, you'll get a little prompt flow icon over here. And I've got a couple prompts I was playing around with here. And what happens is when you open this thing up, you can see the extension is nice because it's essentially giving you a GUI editor to generate the code behind the scenes, because the code files at this time, they're pretty complex for these prompts and these prompt flows. And so it's a code generator is the best way to think about it. But certainly speeds up the process, and so here what's happening is you're setting up the inputs, and and then you have this thing called the section called the joke. And what happens is you have to create connections. And so you can see here I have multiple connections. Let this pull up. I actually have, remember earlier in the session I told you I have GPT-4 installed, and I also have deployed, and also GPT-3.5. So now you can see in here how I can use multiple models within a prompt flow, within a workflow. And then this would be the underpinnings to my Copilot. So see now how we're going from being a multi-tier fancy chat application that uses AI to a real Copilot, right? Because now we're grounding in business data. We're doing, we can do prompt flows and etc. So then, but it gets even better. So what they did at last week at Ignite is they announced something called AutoGen. Again, links are in the repo. You have all this in the slides as well. And AutoGen, essentially what AutoGen does, it allows you to build agents. So here's some examples. They've got multiple patterns. If you go to the website that supports this, I think they've got 6 different patterns now, and about a dozen samples, including one that has 2 agents playing chess back and forth. And so you can see the example here that they're showing is where you have the AI agent is going to get information, external information, by the way. It can call a function. So it's in this example, in this code example, I've looked at the code. It's actually calling out to the ticker symbols and getting the information and then bringing it back. And then it's giving the answer. And then it takes it a step further and it plots a chart based on the change. So this is really fascinating. This is, again, it's called AutoGen. And so what I would submit is that, with these repos, you essentially have, everything that you need to build on top of the AI infrastructure that Microsoft has been very busy laying down and deploying for us over the past 12 months. And so now what I want to do is just go over, I try to keep this session as much demo as possible, but now I do want to just bring it back and wrap up with a couple of slides. So remember a couple things. That's just a couple core concepts here, is that at the core, if you want to learn how to do this and you want to really dive into the underpinnings of AI, and by the way, Copilot too, the Microsoft Copilots, because I will tell you this, if you can dive into this developer stuff and figure out how to build your own Copilot and do it the right way with semantic-kernel the Azure chat if you choose for the client, but really figuring out the prompt flows and how to integrate with business data. I guarantee you're going to be able to make a very easy jump to extending, like, for example, the Microsoft 365 Copilot or the Dynamics Copilot, right? Whichever ones will be allowed to extend. So that's another reason why this is important. So the three important repos that I called out were the semantic kernel, autogen, and prompt flow. Just remember and review, semantic kernel is where it all starts. Remember, like the kernel in Windows NT, the core little kernel that does a lot of the interpretation for the protected memory space, etc. Well, this is just as important to LLM apps, if you will. That's the kernel. This is our semantic kernel. It's core. It allows us to recall memory. It allows us to create plans for our prompt execution and our prompt workflow. It has a connector to connect into Microsoft Graph, and it allows us to do custom plugins or out-of-the-box plugins using semantic function. So I've already did the demo where I went over the architecture. So chat with your own data. Go check out Hugging Face. Microsoft is embracing the open source community. You right now you can deploy. There's literally hundreds of models that you can already deploy. Like I said, even simple ones like a machine learning model to determine if a question is a clinical question. And then once you know it is or isn't, then you can decide what large language model to use and what you want your agent to do. So chat with your data. Oh, remember the chat with your data accelerator that was announced last week at Ignite. That's huge. You got to go check that out, right? And so here it is. Again, there's a link in the slide. Sorry, I just messed up my slides. Down there at the bottom, chat with your data accelerator. It was all fresh stuff. All these repos, not semantic kernel, but the prompt flow, the autogen, and the chat with your data accelerator all just dropped last week at Ignite. So my demo links. And then with that said, I think I'll say goodbye from New York City. Thank you for attending my session. I did one cut. I know it was a little choppy, but I hope it helped. I hope it gave you an overview of what's available to help you take the next step and start building these co-pilots. I can also just close and tell you this is really cutting edge. Folks, as you know, are just getting used to this idea of having a co-pilot that's integrated with Microsoft 365 and Microsoft. This notion of building your own co-pilot and integrating with corporate data and whatnot, we're just in the very beginning of it. And it's going to be a very, 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 very exciting next years coming up in front of us as we need to basically infuse this technology that I just showed you into pretty much every organization on the planet that has a data center. Every country that has a data center, all the organizations within it, they're all doing the same thing we are. Like it's a global effort. And there's going to be a lot of focus on this over the next years using exactly these tools and techniques that I just shared with you. So happy holidays, and don't forget to donate to the Raspberry Pi Foundation, and seriously, happy holidays and happy New Year. And thank you so much for